Okay, in this problem, we are going to focus on getting things into vertex form so that we can get some information out of them. Okay, so this right now is a quadratic equation that's in standard form. It's an ax squared plus bx plus c form, and we want to be able to switch that to vertex form. And the way you do that would be to complete the square. So what you want to do is you want to get everything that has an x in it on one side and everything that doesn't have an x in it on the other side of the equation. So that means I need to add this 5 to the other side over here, and I will do this. I have a y plus 5 plus a blank. I'm going to put a blank on each side equals x squared plus 8x plus a blank. Okay? So just a reminder of how to complete the square. The first thing that you're going to do is you're going to take half of b and square it, and that's what goes in the blank. So b, remember, is your number that's in front of your x, so that's this term right here. So half of 8 is 4, and then if I square that, I get 16. So 16 is going to go in this blank, and I haven't factored anything out, and so 16 is going to go here too. So then what I have is I have on the left side, I have y plus 21. On the right side, hopefully now this factors so that I've got the same thing twice. So this should factor as x and then 16 is a perfect square, which would be 4 and 4. And since it's a plus right here, there either needs to be plus, plus, or minus, minus. This is plus, plus. Notice I have the same thing in both parentheses, so I can rewrite that as x plus 4 squared. So here's where I'm at, and then we'll move that 21 back over and subtract it so that I get y equals x plus 4 squared minus 21. So here's my equation in vertex form, and then once you have that, it's pretty easy to figure out the vertex. Okay, so the vertex, by the way, my a right here, I have this imaginary 1, so my a is 1. It's positive, so I know it opens up. My vertex will be, you'll take what's in the parentheses. Remember, your vertex is h and k. Your h comes from right here, but remember when it's in parentheses, it's the opposite sign, really, is how you can think of that. So that's -4. And then your k comes from this number right here, which would be -21. So your vertex is -4, -21. Your axis of symmetry is just x equals whatever the x coordinate of your vertex is. In this case, it would be a -4. Okay, then we'll do one more where we practice completing the square. This time my a is not 1, so that makes it a little bit trickier to complete the square, but we can do this. All right, so we are going to, again, leave the x's on one side, take anything that is not an x, and move it to the left. So I will add 1. That drops, and I have y plus 1, and then I'm going to put a blank on each side again, equals -3 times x squared plus 6x, oops, I don't want that in parentheses yet, -3 times x squared plus 6x plus a blank. Okay, so the key here is that you need to recognize, remember, that when you have something that's not a 1 in front of this x squared, you have to kind of treat it specially, and you have to factor that -3 out of there. So I'm going to factor in -3 out of this parentheses here, and basically I'll think of dividing everything through here by -3. So -3 divided by -3 is just x squared, and then -3 times -2x gives me positive 6x, and then I'm going to just have my blank. I'll worry about that in a minute. Okay, and then I have not touched anything on the left side. All right, and now I want to figure out what goes in the blank. And remember, it's what goes in the blank would be half of your b value squared. So here's my b, it's at -2. So half of -2 is -1. And when I square -1, I get 1. The problem is people are going to get tempted to put a 1 right there, but don't put a 1 right there because you have this -3 here. So you have to take negative 3 times 1 and actually put a negative 3 there. Okay? All right. So when I look at my left side now and I combine my like terms, a 1 and a negative 3 makes negative 2. And on the right now, hopefully I can take the parentheses part of this and have it be a perfect square. So my fronts, x times x gives me my x squared. 1 has to be 1 times 1. And since this is a plus back here, it either has to be plus, plus, or minus, minus. Hint, 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 minus, minus. Okay, so I can rewrite x minus 1 times x minus 1 as x minus 1 squared. Okay, and then I can just add the 2 back over. And I am there. So here's what your equation looks like in vertex form. Okay, so what I can see is that my a value is right here, and that's negative 3, which means that it opens down. I can see that my h, this gives me my h, it's opposite of what you think. So my h, or my x coordinate of my vertex, is 1, and my k is right here, which is a positive 2. And then my axis of symmetry would be x equals whatever my x coordinate is on my vertex, which happens to be 1. We are going to skip the next problem, but I will tell you that if you want to check it and try it, the equation comes out to be negative 2 times x plus 1 squared plus 4. So if you want to practice it and try it, that's what that one would look like, okay? But I think it's overkill and we probably don't need to do another one.